Hello, dear face. We can start the session. Face, I am audible.
Yes, sir. Yes, sir, you are.
Okay. Face, now we can start the session. Please
Good.
Yes,
do.
yes. In this
Uh,
training on Python programming for AI and data analytics. As we continue our journey in data analytics, today's session introduces us to one of the ability and
Face, your
distributions.
mic is not stable. It's breaking. Please check it.
I think it is okay. Uh-huh. Today's lecture will focus on normal distribution. So there's some feedback loop. Somebody is yes. Today's lecture will focus on basic probability concepts and normal distributions. Probability helps us quantify the likelihood of events, while probability distributions describe how data is spread across different values. Among these, the normal distribution is one of the most widely used models in statistics and serves as the foundation for many statistical methods, machine learning algorithms, and predictive analytics techniques. By understanding these concepts, you will develop the ability to interpret more data efficiently, make informed decisions, and better understand how AI systems handle uncertainty and make predictions. These topics form a crucial bridge between data analysis and machine learning. I encourage everyone to actively participate, ask questions, and follow along with the examples presented during today's session. A strong understanding of probability and distributions will make many advanced concepts in statistics, AI, and machine learning much easier to grasp. It is now my pleasure to welcome our esteemed mentor and speaker, Dr. Meher Chand, Associate Professor at Farid College of Engineering and Technology, Bathinda. Through his expertise in artificial intelligence, machine learning, computational sciences, and data analytics, he continues to guide learners with practical insights and an industry oriented approach to emerging technologies. With great pleasure, I invite Dr. Meher Chand to kindly lead us into today's session. Over to you, sir.
Thanks, dear face, for the nice introduction and welcome, dear participant, to our ongoing series of the sessions of Industrial Training Program. So the today's topic is more advanced related to statistics. Okay. So first, I have very simple question. How many of you are familiar about probability and probability distributions? Please reply me in chat box. So according to that, I would like to manage this session. Yes, no only, so that I can have some idea about you. Yes, Dr. Rachna ma'am, Dr. Jitendra Kumar. I am asking from all the participants, please reply me yes or no if you are familiar about this. Actually, the thing is here main concept. We are how you can do all these things related to the probability and probability distribution by using Python. Okay, so if you have the background about all these things, all type of the distributions, then it's quite easy to understand. If you don't have, then we have to spend some more time on this topic. Okay, I have to organize one special session. Yes, please reply all the participant. Don't hesitate. This is the not the problem. Whether you have studied, it's okay. Not studied, then also okay. But I need to know about you. Saurav Sharma, Praneeth Kaur, Balnupreet, Nilambar Tripathi, sir. Yes, please. अरे yes no कर रहे में तो क्या टाइम लगता है? Just you are required to reply in the chat box. Only 4 participants are there who replied here. So what should I think about the other participant? Okay, idea hai sir. Yes. Ish Mohammed, Arshdeep Kaur, MKA, Balnupreet. Okay, no reply. Okay. I don't get more idea about you. No problem. So what should I think? Okay. So I'm going to share my screen without any loss of time. And yes. So what we are doing today, this topic we are going to cover. If you are interested to work on specifically statistical analysis, okay, and some of the concept just like a binomial distribution or normal distribution are helping us to understand the data set, okay, while we are applying for machine learning or a model, and we want to develop some techniques just like prediction model or a recommendation model by using the techniques which are available for machine learning. Okay, so specifically normal distribution will help us to understand the data set. Or if you have specific domain and you are working in the area of statistics only, you are not required the machine learning or prediction model, then this area is the core part. Okay, so how you can do all type of operations related to probability and distributions. Okay, quite easy, and we can visualize on the basis of the data set, because uh, having the knowledge about the subject and their application both are different thing. Okay, so if we have the real data set, then how the probability play its role, how we can apply for any kind of the statistical analysis and visualization. Okay, everything. And distributions have their own applications, but where you will apply. Okay, just like normal distribution, binomial distribution, Poisson distribution, there are several, but the 3 I have right now, which I will present during this session. And where and how you will apply, and what are their importance when you will apply in the data set. So this understanding is also again very, very important. And without having the understanding about this area, we are not able to apply for real data set. Okay, we are not talking about the theoretical part. Importance is the application part. Okay, if you have any tool, this is not the importance. Importance is if you have the tool, then how you will apply for real life. Okay, and where you will apply. So this understanding will help you more and more help to apply. Okay, so the main objective of this lecture is understand the probability fundamental, learn the probability rule and distribution, then understand the normal distribution, apply the probability concept using the Python, and visualize the probability distributions. So here we are not covering only the normal distribution. We have the binomial, Poisson, and normal. 3 we are going to cover here. Okay, so there are several, just like exponential distribution is also there. So there are various distributions, and every distribution has their own properties. There are some characteristics, and there are application. And on the basis of this application, we can choose a specific distribution for our static analysis. Okay, so here very simple definition, and all of us the probability. Okay, so the probability is the branch of mathematics that deals with measuring the likelihood or chance that an event will occur. So the probability of any event will lie between 0 and 1. If the value of the probability is 0, impossible event. If that is 1, then a certain event. If the value is 0.5, means if 0 lies between 0 and 1. Okay, so the probability of any event will be lie between 0 and 1. If 0, impossible. If 1, then certain event. And if lies between 0 and 1, so equally likely. Okay, so for that, to apply all these, we are required to understand the sample space and the event. Okay, so just like this is a very simple example, rolling a die. Okay, if you had a die and you are rolling, there are 6 faces. So one of them will appear on the top. Okay, similarly, you can take the example of coin. Coin has 2 sides, head and tail. If you will toss, then there will be one side on the top. Okay, so for example, this one, 1, 2, 3, 4, 5, 6, these are the number when you will rolling the die. And if you want to select the event for the even number, so there are only the 3 even numbers, 2, 4, and 6 from this set. Okay, this set is the sample space where all possibilities when you will do some experiment, random experiment. Okay, so these are the possibilities of all the possible outcomes, 1, 2, 3, 4, 5, 6, and the event which you think or which you need, these are 2, 4, 6. Okay, so these are we can say also the favorable event, okay, which we need. Then we have the basic probability rule. Probability of A union B will be equal to probability of A plus probability of B minus probability of A intersection B. So I did not put here the entire concept of, just we need the basic concept only, what is probability and how we can apply. And some of the examples are there, and some basic rule we must be clear. Only then this will be beneficial. Okay, so if multiplication rule, independent event or probability of A intersection B will be equal to probability of A into probability of B. And complement, if one probability is happening, then there are some non-happening. Okay, if you want to get which are not occur. Okay, so here you can see the probability of A. This is the one set where the probability, just like you can see E. E is equal to 2, 4, 6. These are the event which are happen. Okay, if you want to find out its complement, so those element just like 1, 3, 5. Okay, these are the numbers which are complement of E. Similarly, here probability of A complement, if you want to find out, then this will be equal to 1 minus probability of A. Okay, so here also the definition of the normal distribution, very important. And when you have the data set, so this normal distribution will always help you to understand about the data set, how the data is spread. Okay, so the normal distribution, also known as the Gaussian distribution or the bell curve, when you will plot the graph will be like a bell shape. Okay, is continuous probability distribution that describe how the values of the variable are distributed around the mean. Note this point, around the mean. Okay, mean will be the central line. So on the left side and on the right side, how the data is distributed. And in a normal distribution, most observations cluster around the central value. Okay, and while a few observations occur as the value move further away from the mean. So the distribution is perfectly symmetrical. And in that case, mean, median, and mode, these three will be equal if the data is equally distributed or in the normal distributed. So these are the some characteristics. The data set will be image will be like a bell shape, and this will be symmetric. Okay, so the all the data set which will be on the left side of the mean, the same will be on the right hand side, other side. Okay, and mean, median, mode, these will be equal, all these three values. and the total area will be equal to 1. And this is the empirical rule which we have to follow. So the 60% of the entire data lies between plus minus sigma, okay, and 95% within plus 2 sigma, and 99.7% within plus minus 3 sigma. So this is the empirical rule, and we will demonstrate by using Python. Okay, so there are some examples here, but for this normal distribution, I have separate file or for all these. Okay, so we will cover the entire concept. Here is more detail about all these. So here the examples which you can see. These are the libraries which are essential for us, just like import numpy as NP and import matplotlib.pyplot as PLT. We all are familiar. And from this library, okay, scipy.states. So all type of the normal distributions function which we are going to cover now are lies inside this library. Okay, so from this place we will import these three functions: normal distribution, binomial distribution, and Poisson distributions. Okay, and in the very beginning we have fixed the size of the image whenever we need. Okay, so here these are the some libraries which we are required. Okay, and about all this you are familiar, and these are some specific from this scipy.stats library. These functions we are required to import here. Okay, and one more thing. If you want a better understanding about all this, and if uh, you have studied about probability and probability distributions mathematically. So once for those people who don't study these areas of the topics, okay, so you should study from any textbook. Okay, if you need any book related to this concept, I can share with you. Okay, along with I will provide you one cheat sheet for each functions. That will help you in very less time. You can understand entire concept. Okay, so due to the lack of time today and during these days, I'm very quite busy, and I was not able to get this file because the files already I have created, but right now I don't have. Okay, so I will share this file in the WhatsApp group, and all the content and any kind of file if I am sharing, you must go through these files. Okay, so here we have very simple and interesting example. This is the sample space. If you toss a coin, there are two sides. One is head and the other is tail. So all these I am trying to present by using Python only. Okay. So this is the sample space. And how you can store the sample space, you can see here. This is the sample space, head and tail. Yes, don't worry about dear Jitendra. Actually, the thing is, uh, during this single lecture, yeah, everything is possible. Don't worry. In the last day, I will give you one key, and when you will use this key in the future, you will not ask any question from me. Okay, all type of the solutions I will provide you, whether you are familiar about these functions or not. Okay, so how how you can manage everything? We all are faculty members, some are research scholars, okay, and 2 3 are only the student. So mostly we are the faculty members and we are very intelligent. Just we need only the idea. So ideas and the thought which I have, I will share with you, so you can also can implement all these things. You can save a lot of time. You can do all type of the experiments, the things which I present or not present during the session. You can do everything. Don't worry about this, but you should try to implement. Okay. So don't worry. Actually, here we are targeting only the three concept: norm, normal, binomial, and Poisson. Okay, the other distributions which you need in the near future or you wanted to use. So you can easily do everything which you need. Okay, so here the examples which I am presenting here are very interesting. So you can see here, this is the formula to get head. Okay, so you know there is head is the favorable event. Okay, so this is one, and then length of sample space. Okay, so this will automatically calculate how many elements are there in. Either you will use here 2 because the sample size is very small. If sometimes the sample size is very large, then what you will do? You have to use this function length of sample space. This will automatically calculate all the element. Okay, then the probability will be computed by using the formula favorable event upon total number of sample element in the sample space. Okay, so this is the formula. And when you will execute, this will return the probability, which is 0.5. Okay, there is one more example here. You can see, we know in the die there are 6 elements as I show you here. Yes, you can see there are 6 elements. Okay, when you will roll a die, these are the 6 faces. So 6 elements are there and even are 3. So if you want to calculate the probability of this even number or the odd number or even prime number, okay, so it's quite easy. For that, okay, see the second example. So the probability of even, there are only 3 even numbers and these are the total sample space, length of the sample space. Okay, so you can execute here. Similarly, if you want to get the probability of odd number, and we know odd number also 3. So the probability will be remain same. So 50% are even number, 50% are odd number, and the probability is 0.5. If you want to get the probability of even prime number, so there is only one number. There is only one number which is prime and as well as even. So that is 2 number. Okay, so for the even prime number, what you will do? The favorable event will be 1. Then control and enter. So this is the probability of this number, even prime number. Okay, so in this way, you can use this Python to calculate the probability. And here is the simulate coin toss. Okay, so if we toss coin 20 times, okay, and what will be the sample space? Okay, so that this is the random choice. Okay, here you can see the random choice. So each time when you will execute, the sample space will be different. Okay, so here this depend upon how many times you are going to toss. Okay, so here we put here 20 times. So you can control and enter. So this is the sample space when you will toss for 20 times. And each time the values will be different, you can see. Each time values will be different. Okay, because these are randomly. Okay. Then similarly, you can have dice. Okay. So here this is the range. Actually, the numbers in on dice we have 1 to 6. But here you have to mention 1 to 7. Okay. So here actually the value which is we are entering here, this is just like if I write here in the bracket n plus 1. Okay, so we know there are 6 numbers, so we have to take at the place 6 plus 1, 7 number. That's why we have 7. Okay, but when you will execute, when you will present it, this will be numbers will be from 1 to 6 only. Okay, and here is 20. So 20 numbers randomly will be generated for dice roll. Okay. So this also each time will generate different numbers. Okay, if you want to calculate the frequency, okay, so here np dot random dot rand int 1,7, and we have 1,000 time, 1,000 time. Okay, so here we are counting unique values and counts, both are there. How many are unique value? Okay, and their counts. So here you can see these are the values which we have used at this place, and count return counts true. So here this will return both the values. Okay, how many values are unique count? So just like their numbers will be 1 to 6. Okay, so here we will check how many are ones at their count. So count will be unique value will be 1 to 6 only. Okay, but when you will toss 1,000 time, so this will calculate their count. Control and enter C. So here you can see this is the 1. 1 is unique value. 2 is unique value. Okay, so these are the unique value, and along with this is the count. So 1 is 164 times, 2 is 146 times, 3 is 167 times, 4 is the unique number. Okay, but it appears 182 times in this frequency. So these are the frequency of the numbers. Okay, this is the sixth number, and its frequency is 178 times, because because here the range is very high. We try for 1,000 times. Okay, so if manually we want to count, to not possible. Okay, and each time these are the random generated data set. Okay, so each time when you will generate, the numbers will be different. You can see now 156, 179, all the numbers are changed. But when you will take the total sum of all these numbers which are appear here, that will be equal to 1,000. Okay. Similarly, if you want to demonstrate dice histogram, okay, we can demonstrate graphically also. Okay, but during when you study about the probability and probability distribution, uh, we study only the formulas. Okay, but practically we do not apply anywhere. This is the problem. And the second problem is we never visualize what is happening when you are doing this type of the experiment. So everything which you want to visualize uh, uh, for any concept of the probability and probability distribution, we can do. Okay, and when you will visualize, you have better understanding. Not only the understanding, you can have the concept about the application. Okay, so here I tried to insert here some properties along with their application where you can apply and why you should apply. So the application part is much you can understand. Okay, will be very helping, and all these will help you to interpret when you have some data set. Okay, actually the thing is my colleague Dr. Pooja, she is from uh, microbiology background. Okay, so actually don't have any mathematical or statistical background. Okay, so she is good researcher, and the papers which they are publishing, 10 impact factor in SCI, 8 impact factor, and recently we have collaborated, and one paper has been published and 2 are in the pipeline. Okay, so since last 2 years she is working with me. Actually, when she came to contact me, and I asked her what you will do in microbiology, please can you let me some information about your work. And then I asked next question, what are the application of state in your area? and she shared with me one paper. So I surprised to see, actually, this is not her fault. The thing is, when the people who are working in medical sector or in agriculture sector or in microbiology or biotechnology, so they don't have good background in this state, which they need to apply in their work. So just what she has done, only plot the mean, median, STD, or there are one more two terms which she used in and visualize the some graph. And I ask a question: what is the meaning of this standard deviation for your work, and what how you interpret? She told me, just sir, we calculate the values and we don't do nothing. So without interpretation, the problem is how we can interpret our finding. For that, we need understanding about their application part. Why we are using mean, why we are using STD, what will be the impact when you are getting this information, what are the meaning of first quartile, second quartile, third quartile, what are the impact of their use, why we need, and similarly box plot. Okay, so now she is very familiar about all these terms. Okay, so the thing is, just like box plot, we present here, and when you only publish one box plot about your data set, and if you have the understanding, then you will nicely interpret all the information what is you are going to present by using this box plot. Each term you can do. But if you don't have the understanding and what are the meaning of the box plot, then just you will insert the image which is nonsense, no meaning. Okay, that's why I'm saying remembering the formulas are not a big thing. This is completely useless if you don't understand what are the application of the formulas which you are using. Okay, and by using this tool, what you can find, what will be your findings, and then how you are going to interpret. So these things we need to focus when you will use all these things for your research or for your writings, whenever you do. So to spotting all these things, it may be some gap when I will present here, because during the very less time, only 1 hour, everything not possible, but I will provide you some stuff by using the same, you can easily understand. And the secondly, for those people who don't study about this area and you want to use, so the first thing you must read about the concept which you are going to use in your study. Just like we have the probability and distributions. Okay, so highly useful for data analytic and statistical analysis we need. Okay, but depend upon where you are working. So distributions are very, very essential and very important. So here you can see this is the graph. This is the graph. Okay, so I think there is no big problem now. Every concept which in the coding part you will observe, you are familiar, because we have spent a lot of time to understand all these things. So you can see here we are using the histogram and values are using from this place. Okay, the data is randomly. So when you will execute, you can see we can have we can visualize the same outputs here by we can visualize here, and you can see these are the face values 1, 2, 3, 4, 5 up to 6, and on the left side we have their frequency, and we can from this place easily understand what are the frequency of their respective faces. Similarly, you can have the generate normal data. Okay, so this part, this example, I would like it to present from this place. Okay, this file. If you have any question, please feel free to ask. Okay, see, this is the normal distribution. So in these all the three files, I tried to put some definition, what are the properties and their applications, etc. So the normal distribution is also known as the Gaussian distribution or the bell curve, because when you will plot the graph and this will be equally distributed. Okay, and is a continuous probability distribution. They describe how the values are distributed around the mean, and this is symmetrical with the mean equal to median equal to mode. Okay, so here in the formula, I put here the formula also. This is the mathematical formula for normal distribution. So here mean is the center of the distribution, mean, and sigma is standard deviation, spread of the data. Okay, so this is the complete formula, and these are the parameters which are involving. So these are the some characteristics about which we need to understand. Okay, so bell-shaped and symmetric, mean equal to median equal to mode, and total area under the curve will be equal to 1, and controlled by mean and standard deviation, because these parameters are there in the formula. So by these two parameters is by using these two parameters, it is controlled, and follow the rule. This is the empirical rule. Okay, 68, 95, 99.7. Remember this one. And these are the applications. These are some applications, education exam for IQ and healthcare, blood pressure, height, weight, finance, risk analysis, stock return, artificial intelligence and machine learning. There are a lot of applications for this function. Manufacturing and quality control, environmental science, scientific research. Okay, these are the some applications. Okay, if you want to work on the, you are working in this area, so without any hassle, without any loss of time, without any confusion, directly you can use this normal distribution for your insight. Okay, so actually you should have some basic idea about all these distributions where you will apply, and when you are going to apply, you will have some data set. Okay, on the real data set, you are going to apply all these things. See here in this example. So yes, I have executed. I execute the entire file. I restart the kernel. Yes, just 1 minute. Okay, so now it's fine. Yes. So here the data set which we are taking from -4 to 4. Okay, and 500. Actually, the data set which we are using randomly. Okay, norm.pdf. Okay, X is this one, 0, 1. Okay, so this will automatically generate the data set, and then after we will plot here. So plot X comma Y line width we are using 2, and plt.title, this is the title. Then we have the X label, Y label, and grid. And when you will see this graph. Okay, this is a normal distribution. So this curve representing. So when you have some data set and when you will visualize, so this is the standard normal distribution. Okay, and you can see this is exactly symmetrical. So this is the x-axis. This is the x-axis, and this is the main point. Okay, here. So the left, the area under this curve on left side and on the right side, you can easily observe from this graph is equally distributed. And also, if you will change the range, just like if I am taking from this place, suppose that I made here Control Z. Here is 0. And suppose that I am taking here 8. Okay. So the line space I have from 0 to 8. Control and enter. Mm, 0 to 8. Okay. 500. No, sorry. We have to take -8 to 8 because due to symmetrical. Okay. So you can change the line space. Okay, 2 to minus 2 to 2. So the curve will be always like a bell shape. Okay, so this is the normal distributed, and this will help you to understand the data set when you have the real data set. So if the curve, just like caddy curve, okay, is like in this way, so then we can say the data is normal distributed. And here we have the compare different standard deviation. Okay, here we have sigma is equal to 1 because the distribution completely depend upon sigma. Okay, this is the formula. See, sigma is standard deviation, mu is mean. Okay, so if we have the value of STD is different, sigma equal to 1, sigma equal to 2, sigma equal to 3. Okay, you can see here sigma equal to 1, sigma equal to 2, sigma equal to 3. Okay, and very simple to use. Here we are taking, okay, 0 to 1, sigma is equal to 1, 0 to label is sigma to 2. So these values which you can see here, these are the values of sigma. And this is the label. This is the label which you can see here at its base, so that you can easily understand their respective graph. The other things are very simple. And this is the line space, minus 10 to 10. And you can easily observe this graph. Okay, similarly, if you have the data set, yes, I want to show this an example. Okay, here the data set which you can see, when you will visualize, you can see the my cursor is moving. So when you will go to in this way, this is the data which is normally distributed. You can observe this data. Okay, so also when you will use the caddy curve, so this also will appear like a bell shape, like in this way. Okay, so if we have the real data set and exactly we don't have the bell shape, but it looks like a bell. Okay, so similar a little bit there is unsymmetric about left side or right side, just like we have the long tail on the right and small tail on the left, but appears like bell. Okay, so that is also the data is normally distributed. We can consider for real data set. Okay, so this is the normal distributed, and when you will use your caddy curve, you can easily understand. Now there is one more interesting example, but I will not go through the about coding part. Just I want to show you. Yes, first I need to execute this part. Yes, you can see. Okay, so what you are observing here? 68% data, which you can see in the green color. This is the 68%. Okay, and on the left hand side, this is the 16% left tail, and this area, okay, which is white space under the curve, this is also the 16% right tail. Okay, so we can generate like a animated graph also, and here the data lies between 85 to 115 mainly. Okay, 60%, 68% data we have under this range, and you can change this range. Also, if you want to change, you can change the range from this place. From this place, you can change the range. Okay. And here the interpretation of the above, mu is equal to 100% deviation, which we have chosen here 50%, 68% lies between 85 to 115, and this is the mu plus minus 1 sigma. Okay, and 60% below the 85, and 16% observe above the 115, and total outside we have 32%. So 16% on the left side and 16% on the right side. So the total out we have is 32%. Okay, so this part is essential. So this is about the normal distribution. If you have any question, so the thing is, just I visualize here, but you should have some more detail about the probability and probability distributions. Only I put here only one formula, its definition, okay? But if you can have the book, then you can study some more detail about this concept. Then in the similar way, we have the binomial distribution. Okay, quite easy and interesting. So what will be there? Okay, so here. So let's see. Okay, so anyone, can you please let me know about the binomial distribution if you are familiar about this one? Okay, so the binomial distribution is the discrete probability distribution. That model is the probability of obtaining a fixed number of success in a fixed number of independent trial, where each trial has only two possible success or failure. So there will be three terms, just like n will be the number of the trial, p is the probability of success, and 1 minus p will be the probability of failure. So these terms are required, and this is the definition of the probability binomial probability distribution. Binomial probability formula. Okay, so this is the nk p raised to power k 1 minus p raised to power n minus k. This is the required formula. Okay, so where n is the number of trial, k is the number of success, p is the probability of success. So by using this formula, we can calculate binomial distribution. Okay, and these are the conditions for the binomial distribution. Oh, what happened this file? Just 1 minute. This is the Poisson, and this is the binomial. Okay, now it's fine. Thank you. It's fine. So these are the this is the definition. These are the some conditions for binomial distribution. Fixed number of the trial, independent trial, two possible outcomes, success or failure will be there, and constant probability of a success. Okay, so these are the some conditions which we have to keep in mind. And these are the properties. Mean will be equal to NP. What is N and what is the P? All these are defined here. Okay, N is the number of trial and P is the probability. So by using this, we can compute variance. Variance will be equal to NP 1 minus P. P is success, 1 minus P is failure. And if you want to calculate the standard deviation, we have this formula, square root NP 1 minus P. Okay, so the outcomes will be binary. So these are the applications, just like coin tossing, medical testing, manufacturing quality control. Machine learning we can apply for in machine learning for the prediction or recommendation model. And if you want to, there are so many applications in artificial intelligence. Okay, because we have some trial, and when you are doing some experiment, and when you have any statement, so the statement will be either true or false. Okay, there is no other option. So that's why we have a lot of applications of this binomial distribution in AI, in machine learning, in deep learning, in just like robotics to develop any intelligent tool, intelligent machine, just like we can have the weather predictions. There are a lot of applications. Okay, we can find in health science, we can find the applications in finance and insurance, sports analytics, agriculture, medical testing. So these are some applications which you can see, and these are the some real life examples. Number of heads in a 10 coin, defective bulb in the production batch, Okay, if you want to check the students answering MCQs correctly, patient responding to the treatment, customer clicking on an online advertisement. Suppose that if you want to develop some technique about patient suffering from cancer, okay, and doctor has started treatment. So during the treatment, what type of the response is there? And by using the same technique, if we want to develop any intelligent tool, by using the same, we can have the some prediction or recommendation about the medicine which the doctors are using. Okay, so for that we have to need some data collection. So actually we need real data set. So for that we have to need 500 patient at least, so that we can have good database. Okay, and then their treatment which is going on, and what are the changes, whether they are giving the response or not according to the treatment which is going there for some specific cancer. Okay, there are several type of that cancer type. So by collecting the data set, their response according to the parameters which we have decided, we can develop the intelligent tool, and we have to use binomial distribution, and we can create. Okay, so at the end, we will present. I think you should have some projects, all of the participant, and related to this, if you have some data set like you have the response true or false, you can apply. You have to apply binomial distribution. So all these binomial distributions will be help you on your data set. Okay, so the first part you will apply to understand the data set. Then if you have the outcome base, just like
Hello, sir. Your mic unmute.
Sir, voice is not coming.
okay, now okay.
Yes, sir.
Yes.
Oh, thank you, man. Thank you, thank you. Yes. So yes. So here you can see we are applying here. We are computing probability mass function. Okay. So here is the in the binomial package which we import here. There is a PMF function which we are using from binomial library. Okay, and this is the way how you can use X and P. This is the input arguments are there. So according to you, we will not change all this. So this will be in the same pattern. So this syntax you have to keep in mind, and then we can plot all the values just like from 0, 1, 2, 3, 4 up to 10. So this is the values which will take from 0 to n plus 1. So
Actually, this is 11. Okay, but n is equal to 10. So only that up to 10 values will be there. Okay, total numbers are 11. Okay, so when you will execute, this will automatically calculate all the values, success 0, 1, 2, 3, 4, 5, and these are their respective probability. And if you want to plot the binomial distribution, very simple. The values are same. Okay, and here the values which we compute in the above example, and the other statements you are familiar, and this is the graph. Okay, if you want to calculate the cumulative probability, see CDF is there. From binomial, we are using CDF. So this will calculate cumulative probability. Okay, that is for x less than or equal to 5, this value. Okay, we are using here 5 to 10, 0.5. Okay, so here you have to see the values x. See, this is the x, then we have n, and then we have p. Okay, the value of p is 0.5. We will not change that. The value of n also we have fixed, we will not change. Only we can change the value of x. Okay, so you can go through the details. If you have the value of x is 8, control and enter, you can see the value changed. Okay, so this is the cumulative probability. Then you have the random binomial sample. If you need, we can generate. And this is the simulated histogram. Okay, for the above same data set. Okay, so this will also be looks like graph will be similar to not the exact, but looks like similar to normal distributed. Okay, but here the histogram of the binomial distribution. And this is the point is, and all this you can see. And here we have the comparison as we do in the previous normal distribution. The same is there. Okay, so here you will change the value just like P 0.2, 0.5, 0.8, and all these will appear in the same graph for different values of P. And you can compare easily all these distributions. Okay, so here mean and variance you can calculate by using the formulas you can see here. Again, very simple. And at the end also I introduce here animated plot graph if you require, and you will execute, and here you can see the animated graph for binomial distribution. So according to the values are changing, we have this is the animated graph. Okay, so this is the practice exercise you can do yourself. And last one is the Poisson distribution. Okay, so you have to go through the tell about the Poisson distribution is the discrete probability distribution that model the number of events occurring in a fixed interval of the time, space, area, or with the volume. So this is the required formula, probability mass function. You can see here, e raised to power minus lambda, lambda raised to power k upon k factorial. Okay, and this value and this value. This is the lambda. Okay, k, the values of k's are from 0, 1, 2, and the lambda is the average rate of occurrence. Okay, so these are the conditions which you have to keep in mind, and these are the properties, just like the distribution, and the parameters lambda, mean will be equal to lambda, variance will be equal to lambda, standard deviation root lambda, and model count data, and approach the normal distribution for large lambda. Okay, so these are the applications where you will apply for customer arrivals, hospital emergency cases, website visitor, machine failure, insurance claims, phone call, road accidents, AI event detection, and network traffic analysis. So these are few examples where we can use this distribution. Okay, and these are some few examples. So the other things are similar, just you are required to remember this concept, and the application by using Python is quite simple. Okay, so these are the same libraries which you can observe here. Okay, so Then if you want to calculate PMF, so this is the value of lambda, then K, and this is the Poisson dot PMF. So you can easily compare what are the difference there. According to distribution, you will use the function. Then what you want to calculate, PMF, and what will be the input argument. So as you have these values and see the dependencies of the function, and according to that, the order of the input will remain same. Don't interchange all these values, otherwise your outputs will be different. Okay, so only the syntax are important. So this will automatically calculate everything which you need. Okay, control and enter. You have this value. If you will change the value for K is 5, the value is different. Okay, so this is was for 3. If you want to visualize, plot a PMF. So this is the same pattern, okay, to visualize. And this is the CDF to calculate the values. So this is the value. Okay, so here we take x less than or equal to 5. And the formula Poisson dot CDF. Okay, 5,5. And this is the output. Similarly, you can generate a random sample by using the random dot Poisson. Okay, so random samples you can generate by using any distribution. Okay, if you can use here binomial, you can use here normal, and this will automatically generate the samples according to the distribution. And this is the histogram based on this data set. Okay, so you can compare the lambda values. This part also we have done in the previous for normal distribution as well as for the binomial. We have the same comparison based on lambda value. So you can take the lambda is equal to 2, lambda equal to 5, lambda equal to 10. Here you can see here in the formula PMF x comma 2, x comma 5, x comma 10. Okay, markers also we have introduced here, and these are the labels for these inputs. And this is the graph when you will execute. So this is the distribution of Poisson. Okay, and similarly you can calculate the mean and variance. Formulas are we have defined in the above. So actually the thing is you need only the concept of a normal distribution. What are the properties, what are the applications, and the use of these you can see are very quite easy. Okay, so still if you have any question you can ask from me. So at the end we have the animated graph using plotly. So all the graph which you can observe in binomial, normal, and Poisson, we are using plotly graph. Okay, so this is the, you can see, animated graph. So dear participants, this is the all about the today's session. And if still you have any question, please you can unmute your mic and you can ask for me. So I did not focus mainly on basic fundamentals, just only the ideas which we need to understand all these concepts. I insert here. If you need some more detail, we have to follow some textbook. And the most important thing is I will share with you 3 cheat sheets based on binomial, Poisson, and normal. And for the better understanding, more clarity about this concept, you must study this stuff, which I will share late evening. Okay, but right now my next session is going to start. I have left only 20 minutes. So any question, please? You can unmute your mic. Okay. Thank you. So I'm going to share this all this content which I present here right now in your WhatsApp group. You must try. And dear friends, now we have to conclude the session because
Yes.
at 9 p.m. the next session will be start.
Yes.
Okay.
As we conclude today's session, I would like to extend my sincere gratitude to Dr. Meher Chand for today's insightful lecture on probability and distributions. Today's session provided us with a strong foundation in basic probability concepts and normal distributions, helping us understand how uncertainty can be measured and how data behaves in real-world scenarios. These concepts are fundamental to statistical analysis, predictive modeling, and machine learning, making them an essential part of every data professional skill set. I encourage everyone to revisit today's concepts, solve a few probability-based problems, and explore different probability distributions using Python. A solid understanding of these fundamentals will greatly benefit you as we move towards more advanced topics in data analytics and artificial intelligence. I would also like to thank all participants for your active participation, thoughtful questions, and continued enthusiasm throughout today's session. Your dedication and eagerness to learn continue to make this training program engaging and enriching. Thank you all for joining us today. Have a wonderful night, and we look forward to seeing you in the next session.
Thanks, dear participant. I have shared all the content which I present. Okay, so you should try to use all these file. And still, if you have any doubt about all these concepts, you can ask from me. And if you need more stuff, I can provide you. Okay, so thank you and good night.